Hello, and welcome to the first of Ahmad Tutorials. I'm not used to doing this type of thing because, you are usually the one that should be doing this, but apparently you don't know this stuff. And that's okay. Like, I honestly don't blame you. Like, this stuff is hard, and oh my goodness, I would be just as lost as you, basically. But I've gotten some amazing help. Thank you, God. And yeah, let's just get into this thing. This is for the application of radical functions, the sheet that Miss Gary gave us, and I will be doing questions. Just I will be doing questions one, great font, um, two, three, and five. Um, I yeah. Um, I'm not gonna do four because we like did the equilateral triangle like Miss Gary did it with us. I'd mainly like to focus on the ones that we didn't really do, and that's what I'd like to work on. My voice is fading. Let me just bring it back up. There we go. Okay. So one, two, three, and five, and well, I can't really show the sheet. You have to have the sheet with you. Okay. Um, And so, yeah, let's just get into this thing, really. Um, State all answers as reduced radicals. That's what it wants us to do. That's what the guidelines we should follow. The base guidelines, anyways. So, let's start off with question one. A rectangular kid's pool has a width of 3 feet and an area of 22 square feet. Determine the length of the diagonal. That's you texting me right there. If you just heard that notification, that is you. There you go. Vibration. Um, yeah. Okay. So, well, let's draw it. It said a rectangle. And so, let us use this rectangle, shall we? So, a rectangle like that doesn't need to be good. Has a width of 3 feet. Oh, look at that. A width of 3 feet. That right there. And an area of 22 square feet. So let's just add 22. And that's all of it. Well, not all of it, but like that's the only two, like, two variables that we actually get. So length is missing right now. We don't know what the length is, but it does tell us one thing. It says determine the length of the diagonal. And what that means is what we're basically doing is we are going to do this. Pardon me. God. We're going to basically be doing this with our rectangle. And if you could see that right there, that is a triangle. But let's just stop ourselves there because what I'm going to explain here is a bunch of different formulas that we will be using. The main ones of those we will be using are radicals, um, area, um, and what I mean by area, I mean like A equals length times width, and like L, length, and width, define width. Like, that's what I mean in general, is like area, that type of stuff. I don't know to really put it, perimeter, blah, blah, blah. Same thing, but all I'm saying is, like, we're going to be using quite a lot of these in these questions. And so that's important. I don't know why my voice is fading. Maybe I should get some water. It's fine. And we are going to also be using Pythagorean. I don't know how to say it. Spell it. Pythagorean theorem. I'm illiterate. Whatever. Pythagorean theorem. You know what I mean. So let's start off with the basics. What we know. So mind this triangle for now. Just ignore it's not even there. So we have 22 and 3. And we don't know what our length is. It's telling us just put in diagonal, but let's not do that now. So for area, we know that area is length times width. That is what area is. And basically, this right here times this right here, L times 3, somehow equaled 22. And so 22 equals L times 3. That's what we know so far. Okay, I did not mean to do that. Oh, there you go. There's a redo. I'd actually kind of like to move this. Yeah, that's nice. That's actually really nice. Oh, that's fine. I can move this as well. This right here, and this right here. Perfect. Yeah. So we have area equals length times width, which is 22 equals L times 3. Those are the things we have. Now, to find our length, that's what we want to do. We are going to be doing L equals 22 divided by 3. That's to get our length. Okay? And soon, we'll actually be using the Pythagorean theorem real soon. Actually, no. We'll be using it right now, yeah. So with our triangle right here, let's actually draw it out. So our triangle, like this, and there we go. So we know that Pythag is a squared plus b squared equals c squared. That's what Pythagorean theorem is. We know that. And so where would our specific things go? Like, where would our variables go? On this triangle. So 3 is our width. And so right here, look at that. So we know 3 goes here. And now we can't necessarily take area, like for example right here. We can't do that because that makes like no sense if we just did that. That's like it's talking about the whole entirety of the square, like the rectangle. And so basically what we did earlier is, do you remember this? We did this, and so we would take 22 divided by 3 as our length. And afterwards, we would want to put it into our Pythagorean formula. And so that would look like 3 squared plus 22 over 3. I hope I made that somewhat clear. I know it's like been 10 minutes. Hopefully I get better for the next one, but hopefully you're following along. And yeah, we would square that as well. Here, let me put it in bracket to make sure you know it's squared. Okay, it's confusing. Equals c squared. Okay. And so here is where it gets kind of simple for a while before we actually have to use radicals. So far we've used area, like, a equals, and like length, blah, blah, blah. We've used area, and we've used Pythagorean theorem, and soon we're going to use radicals. Right after this little segment, though, we need to find C. That's what we're trying to find this entire time, is C. Okay? And so to find C, what we need to do is this. And so I will erase this part because hopefully you are following along. Yeah, perfect. This is actually really good. Yeah. You should know Pythagoras theorem. So I did not mean to do that. That's very far out. This is working in a weird, wonky way, but I think I can make it work. There we go. So my theorem. Put that there. Push this over here. Here. Okay. So what we need to do next is solve a squared plus b squared equals c squared. And so we would take 3 squared and make that 9. And then we would take our fraction here. And so 22 times 22 is 484 over 9 to equal c squared. And so what we need to do next is make 9 over here a fraction. And so what we do is we'd make it 9 over 1, that, and we'd multiply 9 by the top and bottom because you need to have a same common denominator to add the numerators together. And so that would look like 81, because 9 times 9, over 9 plus 484 over 9 equals c squared. Just do that. So we would add our two fractions together to get 565 over 9 and then have c squared here. And then we would proceed to root the entire fraction and root c squared to get rid of the exponential. And so if we were to do that, that would make it such as 565 equals, see, oh, I forgot to put the over 9. So we changed c squared into c, but we still have to do 565 over 9 square root. And what we do is 565, that's fine, that's rational. What isn't rational is 9 down here, this 9 down here, since it's in a whole entire square root, and we know that the denominator has to be rational. So what we can do is we can square root the 9 and just leave 565 alone. Doesn't need to be touched at all. And so we just have square root on the numerator, because that's allowed, and we'd have 3, because the square root of 3 is 9, and that equal c. And so our final answer of this entire equation would be, because it's asking, it wants what's the width of the kid's pool by an area of 22 square feet, but cut in the length of a diagonal. So it wants to know the triangle's feet. And so that'd be 565 square root over 9 feet. That would be the answer to the equation that we were doing. And we would use area first, then Pythagorean theorem, and then we would do radical work with the Pythagorean theorem just for a little bit, just mainly for the 9, really. And that's it for question 1 on the application of radical functions.